Section 3.1 is going to be about scientific notation. So hopefully you have seen this before, but if not, don't worry, we're going to start from the beginning. So scientific notation is, what is it? Well, first of all, scientific notation is just a way of writing, its a definition is a method to shorten the writing of really big or really small numbers. So instead of writing 45 million, you can write 4.5 times 10 to the sixth. So that is the definition. So why do we use it? Well, in chemistry, we deal with really big and really small numbers. So for example, if you look at 1 tablespoon of salt, that equals 18.4 grams. Well, how many molecules does that have in it? It has this many molecules. So it has I don't even know how big this is. It's super big. There's a ton of zeros here. So if you had to write out all these zeros, it would take you a really long time. Um, and it would be really likely that you would make a mistake because you might accidentally add one too many zeros in or leave one out. If we look at the weight of an electron, so the weight of an electron is, they're really, 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 really tiny. They're the tiniest thing we're going to talk about. And this is how much they weigh. That's the mass of an electron. So it's 0.0000 of tons of zeros, 91 grams. So these are really big and really small numbers, and it's just not very feasible to write them this way all of the time. All right, and then of course there's the mole. So we've talked about the mole before. So the mole, or if you guys remember, it's the number of molecules in a balloon of gas, a 22.4 liter balloon specifically, and it's 602, and this is sextrillion. So it's a really really big number. Or you can write it as 6.022 times 10 to the 23rd. So all this means is that 6.022 times 10 raised to the power of 23, and that is scientific notation. And if you count the number of zeros here, you will see if we go from here all the way over to here, there's going to be 23 spots there. So that's all we're doing is writing it this way to make it more compact. So for scientific notation, first of all, we want the number somewhere between 1 and 9 times 10 raised to some power. So it'll be 1 times 10 raised to some power, and we'll just call it x for now, okay? Or it could be 9, and it can be a decimal. It could be 9.45 raised times 10 to some power. But you notice that there's just one spot here. You will not see it as like 14 times 10 raised to some power. This is not right, okay? So don't do that. You want to have just one digit in front of your decimal point there, raised to 10 to some power. And let's say that it's 4 right there. So for large numbers, our exponent right here that you can see up here is going to be positive. All right, so let's look at this really big number here. Okay, so we know that we're going to want to write it as either some digit between 1 and 9. Well, this one is 19 there, right? Well, we're going to be writing it as 1.9, okay, times 10 raised to some power. Since it's a very big number, we're going to start with our decimal point here, and we're just going to count the number of spots we have to do to take the decimal point in between the 1 and the 9. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so we had to move that decimal point 23 spots, so it's going to be 1.9 times 10 to the 23. And since it's a really big number, it's going to be positive. For really small numbers, we still want a number between 1 and 9, okay? But the exponent is going to be negative this time. That is the difference, okay? Because what we're actually doing is we're dividing. Like a negative exponent just means that you're dividing by 10. So to get this number, we are going to take, once again, we want our decimal point to be in between the last two digits, non-zero digits. Now, if it was just a 1 there, it would be 1. So what we're going to do is we're going to take, that's going to be 9.1, all right, times 10 to the negative this time because it's a very small number. So once again, we're just going to count how many times we have to move the decimal point to get it over there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. We have to move it 28 times to get it there. So that is what that number would look like in scientific notation. And it's much easier to write this than it is to write all of those zeros. That's a crazy amount of zeros. All right, and it makes it easier to do. So here's some more examples. These are more typical of what we will see. So we're going to write 12,500 in scientific notation. All right, remember we want a number between 1 and 9, so we're going to put our decimal point right here. All right, so it's going to be 1.25. So you want to keep all non-zero numbers times 10, and since it's a big number, it's going to be positive. And we have, how many spots do we have to move? 1, 2, 3, 4. Just 4. This time, that's not too bad. Times 10 to the 4th. So that is that number in scientific notation. Now, let's look at it if it was a small number. So we go to the first non-zero number, which is 1 here. So we're going to have the same start again, 1.25. Now, it's a small number, so it's going to be a negative exponent. And we just count how many times we have to move the decimal point. 1, 2, 3, 4, 5. So it's negative 5, okay? So you can see that's 1.25 times 10 to the 4th is that number. It's a large number. 1.25 times 10 to the negative 5th is this number on the bottom, a small number. All right, for addition and subtraction with scientific notation. So we are going to be doing this, especially with some of our conversions. You input it just as you see it. So when it depends on what type of calculator you have, and we will practice this in class. You can also look it up online. But depending on your calculator, there's lots of different buttons you can use. So if you have EE, so let's use some example. Let's use 2.5 times 10 to the 4th, okay? EE, you would just write 2.5 EE is just a button, and then 4. That would be how you would input that into your calculator, and you should get this number. Sometimes there's the 10 to the X button, so then you would write 10.5, and then you would do the 10 to the X button, and then you would just put in 4 for your exponent. If you have a Y to the X, you can actually, what you would do, 2.5, you would have to push the multiplication button times 10, and then you do the Y to the X button, and then 4. And then lastly, if you have a caret right here, you can write 10.5. You have to do a multiplication times 10, use the caret button, and then 4. So that's how you would input those into your calculator. If it's a negative, you usually just put the negative sign in front of it. I think it's if you have one of the calculators you need for Algebra 2, you have to actually use the negative with a little parentheses around it instead of the subtraction button. All right, so for these, I'm going to go ahead and use a different app to show you guys how to actually calculate these. So I'm going to use Desmos so you can kind of see how you would input these into your calculator. Okay, so here we are on Desmos.com, and feel free to use this website if you would like to do your work. You will not be able to use it on a test though, so you will need some sort of graphing calculator. Or not graphing, but scientific calculator. So this is just the scientific calculator on Desmos.com. There'll be a link to this under our topic. But let's do the first example here for addition of a scientific number. All right. So we're adding. So we go 2.56 times 10. And here we're using the A to B. It's similar to the Y to the X button I talked to before. 10 to the 4th. Okay. And that, I think we have to use that little, you have to use a little arrow after that. We're going to add that to 6.58 times 10 to the 3rd. All right. Okay, we're going to go ahead and calculate that. So we're going to push this little blue button, And that gives us the number there. So now this is not in scientific notation, so you do have to count and put it in scientific notation. So that gives us 32,180 or 3.2, I'm going to round, 2 times 10 to the fourth if we count over. 1, 2, 3, 4. Okay? Now let's go ahead and start with the second one. So the second one was 1.5 times 10 to the negative 6, negative 6. All right, we have to use the number to go back down, minus 4.3 times 10 raised to the negative 7. All right, let's go ahead and go back down again. We input that number, and here it gives us, oh, well, that gave us in scientific notation, which is nice. So it gave us 1.07 times 10 to the negative 6. All right, so you can see it just took a little bit off because the second number is so small. All right, so for multiplication and division with scientific notation, multiplication is pretty easy. It's just like addition or subtraction. You input it directly as you see it. All right, here we are in Desmos again. Now we are going to practice the multiplication of scientific numbers. All right, so our first one is 6.52 times 10 raised to the fourth power. To go back down, times, and you might notice that for times here, they just use a little dot. 2.58 times 10 raised to the second power. We can go over and we calculate that and see, you can see it already did it for us. It's not in scientific notation though, but I'm going to round for 3 non-zero places. So it's going to be 1.68 times 10, and if we count over, that's going to be 1, 2, 3, 4, 5, 6, 7 spots that we have to go over. All right, let's do our next one. So the next one is, oops, here we go. Right, our next one, that just changed the number because I accidentally put that 3 there. But let's see, our next one is 3.54 times 10 raised to the negative 9th. Right, we have to go over, times 8.97 times 10 raised to the 10th power. All right, so let's look and see what that is. Oh, okay, there we go. So that is 317.538. If we round for 3 places again, that would be 3.1. Now, since there's a 5 there, it's going to bump that 7 up to an 8. So it'll be 3.18 times 10 to the second power. We just have to move the decimal point over 2 spots there for multiplication. Division is different, okay? So division, if you just input it like this directly into your calculator, it will take the 6.52 times 10 to the fourth, and it'll divide it by 2.58, and then multiply, because of PEMDAS, it'll multiply the entire thing times 10 to the 2. So you need to get it to multiply by the entirety of the second number, you need to put parentheses around the second number. So we would have to put parentheses here and also here, and I will show you guys that in Desmos. Right, and then all right, and now here we are in Desmos, and we're going to practice the division of scientific numbers. So the first one we have is 6.52 times 10 raised to the fourth power. All right, we'll go over. We're going to divide that number. And it's fine if it looks like that. It's doing it. We have to use the parentheses around 2.58 times 10 raised to the second power. There we go. And we can close our parentheses there. Oops, I guess we didn't have to do that. Let's go back. There you go. Oops. Bear with me. There you go. All right, so here we have our 6.52 times 10 to the fourth divided by that number. And if we input that, you can see the answer is going to be 2.5. I'm going to round 3, all right, times 10. And we just have to go over 2 spots there, times 10 raised to the second power. All right, let's try our next one. So let's try, oh, here we go. Gotta that in. Our next one, here, let's delete that. There we go. Our next one is going to be 3.54 times 10 raised to the negative ninth power. We're going to go over, we're going to divide that by, let's use parentheses, 8.97 times 10 raised to the 10th power. All right, and you can see it already gives us our answer there, which is a very small number, 3.95 times 10 to the negative 20th.